Hello everyone, welcome to our Simulink Student Challenge 2019 video. My name is Mustafa Saraoğlu, and in this video I would like to show you how we use MATLAB Simulink to program these EV3 robots, the detector camera, and how we use them in coordination using real-time communication. The goal of this project is to have a safe town where autonomous vehicles drive freely without colliding with each other. So let's get started. I will be presenting the roles of my teammates and also which toolboxes and add-ons they have used throughout the video. MATLAB and Simulink toolboxes provide simple and practical examples to kickstart your project, so we have also used a bunch of them. This is how we plan to start building the safe town. A simple map with a few intersections would be enough to begin with. In our project, we plan to use a camera to detect the vehicles, send this information to a workstation where we can run additional algorithms and then send messages containing go or wait commands for the robots. These commands are sent using real-time UDP through a Wi-Fi router. To program the vehicles, we have developed Simulink and stateflow models, and then we flash them using the support package for Lego EV3 Mindstorms. T-Hung has first developed model-based vehicles in Simulink. Before we start flashing the models into hardware, we had to make sure that the models do not contain inherent bugs and work as intended in ideal conditions. Beginning with a simple vehicle following example using the model predictive controller, he has developed a comprehensive autonomous vehicle model using stateflow and Simulink together. Of course, modifications had to be made later on to run the model on real-time hardware, but it provided the required insight. Duke has worked on calibrating the actuators of the Lego robots. Since sensors and actuators are quite heterogeneous hardware, it's not easy to build a model that suits all the vehicles. In the meantime, to have a robust communication with the workstation, the Simulink and stateflow models had to be feasible. Here you can see the added line tracking algorithm and the UDP blocks on Simulink, which are required for the hardware. Communication with the workstation is provided via Real-Time Universal Datagram Protocol (UDP). A practical Simulink UDP add-on was enough to transfer data through a Wi-Fi router. In this section, we are going to show you a few driving scenarios that we have used to test our control algorithms. We use color markers before intersections for localization. The rear end of the vehicle reads the color code and then translates that as a state in the stateflow machine. UT works on image recognition and vehicle detection algorithms. He has trained a bunch of different networks using transfer learning and tried a few different algorithms to train the detectors. First of all, he has used the Ground Truth Labeler app provided with MATLAB to label the regions of interest with the help of the temporal automation algorithms provided by the computer vision toolbox. Then, he has trained the detector using the created ground truth data offline on a single robot video that we have captured with our camera. Next, we have tested its performance on a video of two robots and modified the algorithms to get a clear bounding box of the detected vehicles. In the end, we have decided to use an ACF detector for this project. We have identified the coordinates of the intersections according to the map and then used the occupancy of the boxes to send information about which intersections contain at least a vehicle at any sample time. In the future, we plan to train our detector to identify intersections for custom maps and also detect collisions between vehicles. To use the detector algorithm in Simulink, which was trained in MATLAB, we have inserted a MATLAB system block and run it using the interpreted execution on the workstation. SafeTown Project is still relatively young, so there are many more features that we would like to add in the later stages of the project. You can download the current files from the MATLAB file exchange link in the description below. We would also appreciate any feedback from your side, so feel free to comment on the video or contact us directly via our emails. Thanks for watching.